Welcome back. We are to the final part of chapter 2, and we're going to talk about variation today. We're going to start with direct variation, and an example of that is our distance, rate, and time equation that we've already used in class. And if we let the rate be a fixed constant, then we can say that the distance increases and decreases with time directly. So we say the distance varies directly as time, or is directly proportional to time. One example of this would be as one thing gets larger, the other gets larger, and vice versa. When you go to buy gas for your car, the more gallons of gas that you put in your car, the more expensive it's going to be. So as one goes up, the other goes up as well. As one goes down, the other goes down. And so what we do is we say that y is directly proportional to x. So they're not equal. However, if I put a constant in there, that'll make them equal. And in my gas analogy to price, you know that if you buy 3 gallons of gas, it doesn't cost you $3, right? So the K in that case, the constant would be the price per gallon of gas. Maybe I think it's up at $4.50 now or something. Where K is the constant of proportionality. And when we say constant, that means it's a number that doesn't change, whereas X and Y can change. So we'll do an example. If Y equals 6, when X equals 2, find Y when X is 5. So the first thing we're going to have to do, actually, this whole lesson today, is find K. So we use our formula here. Y becomes 6, X becomes 2. Solve for K. We get that K is 3. Now that doesn't change. So when you give me another X, like 5, we're now here. Y equals, instead of K, X, it's now Y equals 3X. So now when we replace X with 5, we have 3 times 5, which is 15. There's an example of that. Inverse variation is the opposite. Inverse variation is when, as one variable increases, the other one decreases. So, for example, if I were to say the more miles that I drive, the less gasoline I will have in my car. So as one gets large, the other one gets much, much smaller. And we use this, y equals k over x. Again, k is the constant of proportionality. And then similar to that, we have joint variation, where there may be more than one thing that is causing, there may be both a direct variation as well as a inverse variation. There may be 2 direct variations. There could be lots of things. So what we would say for a joint is that y is equal to k. And this one specifically, y is jointly proportional to x and inversely proportional to the square of w. So directly with x, inversely with the square of w. All right, so let's do our example. The monthly payment P on a mortgage varies directly with the amount borrowed from B. If the monthly payment on a 30-year mortgage is $5.75 for every $1,000 borrowed, find a function that relates the monthly payment P to the amount borrowed for the mortgage with the same returns. Then find the monthly payment P when the amount borrowed is $225,000. All right, so here we go. So we're going to let P represent payment. And that's going to be directly proportional to the amount that was borrowed. And we know that the payment is going to be $5.75 for every $1,000 borrowed. Well, this means K, I divide both sides. K is 5.75 divided by 1,000. And that is going to move the decimal around quite a bit. So 5.75 divided by 1,000. Yeah. So this is going to be 0.00575. Which means our new function is going to be P equals 0.00575 times B. Now they want to know what the monthly payment is going to be when the amount that was borrowed was 225,000. So now I'm going to go P equals 0.00575 times 225,000. So I have that number already in here. I'm going to go 225,000. Oops, times the answer, meaning times this number here. That brings it to monthly payment of $1,293.75. There we go. Kind of cool. Next up, a couple more examples. The length of a violin string varies inversely with the frequency of its vibrations. So let's do that. So the length of a violin string varies inversely with the frequency of the vibrations. We'll call that B. If a string is 8 inches long, vibrates at a frequency of 640 cycles per second, what is the frequency that of a string that is 10 inches long? So we'll get to that. We need to get K first. So I'm going to multiply both sides by 640. So K equals 8 times 640, 5120. All right, so now it's saying, what if the length is 10 inches long? Let's write this as a function first. So L equals 5120 over B. And now let's let L be 10. Multiply through by V. Divide by 10. B is going to be 512 cycles per second. Make sure you read the question clearly. Is it inversely or is it directly proportional? And so on. The volume of a cone varies jointly as its height h and the square of its radius r. So let's do this. V is k times h times r squared. A cone with a radius of 4 centimeters and a height of 6 centimeters has a volume of 32 pi. So 32 pi equals k times the height is 6 and the radius is 4 squared. And so we get 6 times 16. So 32 over 96 pi is what k is. 32 pi over 96. And that's going to reduce. I'm going to use that reducing trick again. So 32, don't worry about the pi for now, divided by 96. And then I taught you that trick where we can just hit math, change to a fraction. There it is. So this is 1/3 pi, which means V is now 1/3 pi h r squared. And by the way, that really is the formula for the volume of a cone. So now it wants to know, find the volume of a cone having a radius of 15 centimeters and a height of 30. And I'm going to get us an exact as well as an approximate. So 15 squared times 30 divided by 3. So our exact answer is 2,250 pi cubic centimeters. So here's our exact answer. And if we want an approximate answer, we just multiply that times And I have a pi button on mine. You have a pi button on yours as well. So this is about 7,068.58 cubic centimeters. Not too tricky stuff. Hope that helped.